today we are, this is section 1.3, using the distance and midpoint formula. Today we're just talking about the distance formula. And so the distance formula helps us to determine the length of a segment in two-dimensional or three-dimensional space, but this one is just 2D. And so if we have a line segment somewhere in space, we have some ordered pairs that we can give it, x1, y1, and x2, y2. And we have a lovely little formula, the distance d for distance, is equal to a giant square root. Now, to find the length of something, we had a little discussion about this yesterday. To find the length of something, we subtract, right? If we want to know how long a segment is, it stops at 12 and starts at 5, we can subtract, right? 12 minus 5? Okay, so that's what we need to do. We're going to take... That's hysterical. All right. My bad. That's okay. It happens. Okay, so what we're going to do is we're going to take our x coordinates. All right, so I'm taking my x coordinates. And so we need to find that distance between the x values, so we're going to subtract. We're going to subtract x sub 2 minus x sub 1 and square the result. I don't like just giving out formulas, but this formula comes from the Pythagorean theorem, okay? And it works really, really well. Today we're learning the formula. In the future, we're just going to use the Pythagorean theorem because it's like super easy. But we're going to use the formula and our calculators today. And then we need to add it together with our y, the change in the vertical distance. So the y coordinates, we want to use, again, y2 minus y1. So y2, y sub 2 minus y sub 1, and again, square that. So it's this big giant square root with bubbles inside, and this gives us the distance, the length of the segment, the distance between the 2 points, okay? So here on number 1, we want to find the distance between the 2 points, and you are going to want calculators, so we can all practice with calculators. So if you don't have your calculator, come grab a calculator. All right, so we want to practice here. We want to find the distance between the 2 points on the graph. Now, of course, in order to do this, we have to make sure that we know how to label points. So when I look at this first point right here, in which quadrant is this? First. No, second quadrant. Yeah, quadrant 1 is the top right, and it goes in a circle from there, counterclockwise. So this is quadrant 2, quadrant 3, and then quadrant 4. Just in case you were curious, I like to remind people of that. It's weird though, right? It's weird that it starts over there instead of top left, right? That's what you'd think. But no, yeah, it goes that way first. All right. So ordered pair. What is that ordered pair here in quadrant 2? Negative 5. Yeah, negative 5 up 3. Very good. My daughter, who's 11, we were just randomly talking, and she was like, to graph stuff, you have to run to the elevator first. So you have to go horizontally first. You got to go to the elevator first, and then you can go up or down on the elevator. I was like, oh my God, that's the cutest thing I've ever heard. So yes, we do have to move left and right first, and then we can go up and down. So as we're getting to this point, we have to move left first, so that's the negative 5, and then we can take the elevator up. Okay? Does that make sense? Oh, I thought that was so cute. All right. Now, this ordered pair here in quadrant 3, what's that ordered pair? Negative 2, negative 3. Very good. Again, we have to get to the horizontally first. We have to run down the hallway. So we're going to run horizontally to negative 2, and then we can take the elevator to the sub-basement. Sub-basement 3? Yeah? Okay. That's so cute. All right, I'm going to go ahead and just write these ordered pairs, negative 5, 3, and negative 2, negative 3, up top. And you want to make sure that you realize this is x sub 1, y sub 1, because they have the same subscripts because they're from the same ordered pair. That's the first one. Now, does it matter if I change the order of those two ordered pairs? No, it doesn't really matter. But they are presented together. So this is x sub 2 and y sub 2. And now to find the distance, I am going to set up my giant radical. And I'm going to set up my bubble squared plus a bubble squared. I like to get things set up that structure, and then we can fill it in from there. And first, I'm going to subtract my x's. So what should I do?
Negative 2 minus.
Yeah, negative 2 minus a negative 5. And then I'm going to subtract my y's. What should I write for that? Negative 3 minus 3. Very good. So I'm subtracting my green stuff. I'm subtracting my red stuff. All right, I'm going to do a little bit of cleanup. And I think this is important that we take a little second just to make sure we know how to do this. What happens when you have minus a negative? And become a plus? Yes. So those double negatives turn into positives, and we have negative 2 plus 5. What is negative 2 plus 5? 3. And then we have to square that. What is 3 squared? 9, yes. All right. And then we have our plus sign. And now over here we have a negative 3 and a negative 3. What's that give me? Negative 6. Okay. Now real careful here. We have a negative 6, and then we need to square that. What do we get?
36.
Oh, I heard negative 36, and I had positive 36. So this is where we need to be very careful. Negative 6 is inside parentheses, and we're squaring it, which means it's really negative 6 times negative 6. Everything in parentheses is being repeated 2 times. So it's always going to be positive here, okay? So this is the most common algebra mistake. Negative 6 squared equals what?
36.
Does it? What I wrote there, negative 6 squared, no parentheses, does it equal negative 36 or positive 36? Negative. Why? What is that exponent of 2 affecting? Just the 6 in this case. It's just close to that 6. It doesn't touch the negative. So this one, the negative is hanging out, and the 6 is being repeated 2 times. This gives us negative 36, okay? This is the distinction between parentheses. This is saying the 2 is affecting everything inside those parentheses. So we repeat everything inside those parentheses 2 times. Do you see the difference? Okay, this is the #1 algebra mistake. And if I teach you anything this year, I hope it's the difference between negative 6 squared and negative 6 quantity squared. Okay? Interesting discussion? Okay. All right. Now then we have here, we have the square root of 9 plus 6 is? Whoa, what? 15. Okay, there we go. All right, wait a minute. 30, what is going on here? Oh, I wrote 6. You were right, Paxton. I'm sorry. I wrote 6, not 36. This is negative 6 squared, which is positive 36. And thank you, Paxton, for being ahead of me. All right, now we get the right answer here. 9 plus 36 is 45. Very good. This is an exact answer. It's beautiful. It's really perfect. But today, and most of the time in geometry, we're actually going to use our calculators to get an approximation. So in your calculators, you're going to do second square root. Do you know how to do that? Second square root of 45. And most of the time, we can just round to the 10th place. So this is 6.7 approximately, rounding to the 10th place. 6.7, yep. Life would be so much easier for math teachers without that silly meme. Okay. All right, once again, looking at number 2, we have x1, y1, and we have x sub 2, y sub 2, because that's our second ordered pair. We're giving it a subscript of 2. And I'm going to find the distance between the points. So I'm going to set up my giant square root, then a bubble squared plus a bubble squared. And then I can fill it in pretty easily. What should I subtract first? Negative 4 minus 3. Interesting. And you did that x1 minus x2. Is that okay? It is absolutely okay. Negative 4 minus 3 rather than 3 minus a negative 4. Either one is totally fine because it turns out we're going to square it anyway. So we'll always get a positive result, which is what we want. And then y2 minus y1, I'm going to do negative 1 minus 1. And a little bit of cleanup here. I'm going to have, let's see, what is negative 4 subtracting 3? Negative 7. Negative 7. Quantity squared is? 49. Negative 7 times negative 7 is 49. Negative 1 minus 1? Negative 2. And negative 2 quantity squared? 4. Negative 2 times negative 2 is 4. Very good. And so we get the square root of 53. 53. And we're going to approximate that. So the square root of 53 is about 7 point, if we're rounding to the tens place, what should we write? 7.2 or 7.3? 7.3. Why?
Because you're rounding up to the highest number.
So when we look to the neighbor, the tenth place neighbor, so that's the 8, he's 5 or more, so that 2 we're going to increase to a 3. Okay, great. All right, last one here. Using the distance formula, we have x1, y1, and x sub 2, y sub 2, and we're going to plug it into our formula. Again, I'm going to set it up, giant square root. We've got some bubble squared plus another bubble squared. And what should we put inside our first bubble? Good. 11 minus a negative 7. We're subtracting our x's. Very good. And then in our second bubble, we're going to do 3 minus a negative 2. Beautiful. Subtracting the y's. 3 minus a negative 2. Beautiful. And then from there, what is 11 minus a negative 7? 17 almost. 18. Ooh, 18. 18 squared. 324? Oh! I got it right! That was awesome. 324, 18 squared. 324. Okay, here we have 3 minus a negative 2, which is 5. 5 quantity squared is 25. Very good. And so we get the square root of 349, which is approximately 18.7, rounding because of the 8 tells us to round up. The neighbor tells us to round up. Okay, questions for me? Okay, fantastic. Today we are doing a little stations activity around the